Aloha. In this lesson, we'll be talking about comparing data types and common errors. So you can use relational and equality operators on strings, integers, floats. However, do not use equality operations on floats because floats are actually imprecise representations of numbers. What does that mean? Well, Python rounds the number because of the problem of storing base 10 numbers as base 2 numbers. And if you really want to understand that in detail, I've got a link in VS Code, which I'm about to share with you right now. And that is a link to the Python docs. Up here at the top, you can see the link. This is a really good repository of information. If you ever have questions on how to use a function or something like that, Python docs is one of the best places to go for it. So anyways, speaking of that floating point comparison, don't use equality. It'll actually give you an answer. Sometimes it's accurate, sometimes it's not. And because of that, you can't trust it to give you an accurate answer. So don't use it for floating points. We can use it for a variety of other types of operations though. So when we're doing, let's say, numbers, like over here, if we've got two numbers, the type of operation that will be done is an arithmetic one. So A greater than B, it'll compare the two numbers as numbers, and it will give you a result. So if we do a quick run here, we can see that A is not greater than B. So if we were to change this to A and say, let's say equals, double equals for equality, not single equals, which is assignment, and we were to run it again, we'd get true. So they are true. So if we ran this, we should get false. They're not equal. And if we were to say A not equal to B, again, we should be back to true because they're not equal. So we can use equality and we can use not equality. We can use the greater than, the less than, and we can even use the less than or equal to. So all of these are valid. You can use these for numbers. So let's continue on to string comparisons. Well, actually, before we do string comparisons, let's take a look at what happens when you try something a little bit unusual. So let's say you want to compare a string to a number. Does that make any sense? You wouldn't be doing it by math. You wouldn't be doing it by string necessarily. So when we try to do this, we should come up with a type error. So let's go ahead and run. And sure enough, it gives us a type error. It says greater than not supported between instances of string and int. And they tell us really nicely that it's in line 13, and this is the name of the file that we've got the error in. So it tells us where we can find it. And over here, it shows us what exactly is offending right here. So this is really nice. This is what we call verbose errors. So let's go ahead and comment this out and go and check out the next section. The next section, we're going to look at string comparisons. String comparisons is pretty interesting. So strings are actually representations of characters, and they're stored in different, what we call encodings. So we use different encodings to represent these letters and characters. So ASCII is the American Standard Code for Information Interchange. That was our first one. This is, everything that you can put on a keyboard can be expressed in here. The problem is it doesn't do you much good as you go into other languages like Japanese. So if you want to do Japanese, you're not going to be able to express it in ASCII very well. So we came up later with different encodings like UTF-8, UTF-16, and UTF-8 is the Unicode standard. So you'll see a lot of people using UTF-8, and I believe if you look down here at the bottom, VS Code actually defaults to UTF-8, and that has a number of implications. But what's going on here is when we do a comparison with strings, it's going to look at each and every character in the sequence, and it's going to take it and it's going to convert it into the ASCII or the UTF-8 or whatever representation. So I know that in ASCII, I believe capital A starts around number 65, and it goes up by 1 for every letter of the alphabet. I'm not sure about UTF-8. I think it might be around 97 or something like that. What it's going to do is it's going to convert each and every character to a number, compare them. If they're equal, great, we continue to the next number. As soon as it hits one where it's not equal, it'll knock out of this, and it won't do any more comparison because that would be inefficient. So here it should knock out at the first character because capital M and lowercase m are different characters. So we're going to test this, and then we're going to test the one below it where we actually have them equal. So if we click on the run here, we get false, which is as we expected because lower and uppercase are treated differently. And then we've got equal, true for the other one. And we can use, again, the pound or the bang equals. So if we do that, we get false. So because those are equal, if we were to go up here and change that to bang equals, and we did it, we should get 2 trues. So you can use the different things like that. So it would also be interesting to see what happens if we try a greater than or equal sign here for equal ones. So what do we get? We actually get true. So we can ask here, is capital Manapua greater than lowercase Manapua? And it is not. So yeah, so it's doing a comparison in there that tells us it is not. So yeah, so it's less than. So I'm guessing that the lowercase m comes first in UTF-8. So anyhow, that's how we do string comparisons. And that is convenient. The next thing we're going to look at is lists, tuples, and dictionaries. So lists, as you recall from earlier, are simply a collection of a container of elements, objects. So in this list, my list, I've created a 0, 1, 2. I've created your list, which is 0, 1, 2 as well. I've created their list, which is 0, 2, 1. It's the same elements, but it's in a different order. So we're going to find out here about the rules for lists. So essentially, it's going to go through and they have to be the same elements in the same order. So when we go ahead and run this, what should we see happen? Is my list equal to your list? I would say so. That should be true. My list equals their list, 0, 1, 2, and 0, 2, 1. It's the same elements, incorrect order. So I'll say that's false. So true, false should be what we get out. And sure enough, we get true, false out of this. So that's lists. We'll go down, take a look at tuples. Tuples operate pretty much the same way. It's also another container. We've got 0, 1, 2, 0, 1, 2, 0, 2, 1. So we're going to test to see if my tuple is equal to your tuple, and we'll also check to see if my tuple is equal to their tuple. So let's see what happens here. So when we run it, we're going to get true and false, just like up before, in the example before this, for the same reason, because it's not the same order here. It's the same elements, different order. So we go ahead and comment out this. Now we're going to look at dictionaries. Dictionaries are a little bit different. So dictionaries are value key pairs, but they don't have an inherent order. They actually, if you dig into it, and I forget which version of Python 3, but they do have an order at some point, but probably for backwards compatibility, they haven't actually, they're keeping it the way it used to be, which is it's considered unordered. So in order for things to be equal, and when you're comparing dictionaries, the keys have to be equal to, and the keys have to be equal, and the values that match with it have to be equal. And I just realized that I have set up an example here where I'm not actually doing variables. I'm meant to be doing strings. So let's go ahead and add that in here. A little bit of an embarrassing faux pas, but it happens to all of us. So we're turning these into strings. So now that we've done that, let's go ahead and run it. And let's see, we're looking at this. My dict is, so my dict is A is 1, B is 2, C is 3. Your dict is the same thing. And their dict is not exactly the same thing. We've put them in different order, but as I said before, order doesn't matter here. So we're going to go ahead and run this and see what happens. And we get true and true, which is kind of what we expected, because these are equivalent because they have the same number of the same keys. and they have the same corresponding values. And it's the same here, even though we've entered them in a different order, it's still considered the same. It's still considered equal. So that's why we got true and true. So moving on from that, we're going to look at some of the common branching errors that we see. One of the biggest problems that we see is when people forget to use the double equals for equality and they just use a singles. Single equal is actually an assignment. It's not an equality check, which is kind of confusing because in other languages out there, you can use them, you can use the single equal sign. Like I think VBScript uses the single equal sign. JavaScript goes a step further. You have the equal sign for assignment, but then you've got the double equals to check if the values are the same, and triple equals is used. And that's even nicer because it checks not just the value, but the types of the things being compared. So that's very useful. So anyhow, as it says here, it results in a syntax error if you use a single equals instead of a double equals, but other languages you may not have the same results. Also, another non-existent relational is the less than or greater than sign, and that is actually equal in other ones, like VBScript uses that as the inequality for the bang equals, the exclamation mark equals. So it does have value and it does have meaning in other languages, just not Python. So keep that in mind, and that is it for this lesson. I'll see you in the next lesson.